Yeah, hello there. Hi. I cannot believe it. I can't believe it came back and got me again. The same thing came and got me again. Remember I told you I kept rewriting this function for some reason? Well, I was doing something else to do with this string token, wherever it is. String token. And it wasn't working right for some reason. And it wasn't in my test here. Here's a string, and I want to break it up into tokens, and it wasn't trimming off the white space on the end here. Yeah, I was thinking, well, that's weird, if I do like a trim right, that works. And then I tried it, and it didn't work. And I'm thinking, well, that's impossible. It couldn't be. For all these, all this time that function's not been working, and I never noticed. And I guess I just never noticed. And I searched in the history, trying to find out when did that happen. And I found it. Oops, but it's not here. It would be in this one, in this file. Here. Somehow, at this point, I was adding a bunch of assertions. I was introducing this string is empty macro, and I got two functions confused or something. A lot of them look the same. Oh, and then, yeah. I implemented last of, and that must be what happened because I was trying to group them together, and then this somehow or other, this double equals turned into a not equal, and so it was broken again. So I don't really need to mention this, but it is kind of a good example of another. It led to me saying, okay, well, I've had enough of this function. I'm moving it out of this file that's always getting edited, and I'm going to make the two things look exactly the same. Alright. Here's find first not up. Here's find last dot up. Identical now, except for the return value. Okay, that's it. Now there's no possibility of me messing this up ever again. And the part that might be of interest is the implementation of this and the Widecar version. Not that the code's the same, but I used a template, see? Because I wanted to use the same code template. And the only difference here is in how the length is computed and the type of character type. So here's an example where you just make this is not a template for general use. It's just internally used, and then I call a specific one that I want for the two versions. One uses car and string length, the other one uses wcar and widecar string length. Same implementation. Now, the other thing is this list thing is done. And I've uploaded all this. And I've added in all the necessary support to make this a regular old object that you can do whatever you like with. It has a copy constructor. It has a copy operator. Okay. And you can do things like copy. Well, I'll run this first. Let me show you the string token work. Just while the one was on that subject. See? Tokenizing by white space, or if I want, I can go backwards. And it'll do it in reverse. Okay, so that's one thing. Oh, and you can trim things again. So here's some of those tests I was running. We'll try out some of the functions. Let's see now. Well, that's quite a lot. Probably more than I want. So here I've got two lists filling one up, and here I'm locating something. I want to check the insert after. So for the first list, after the fifth position, I insert this, insert it after fifth position, and then print it out. There it is, see, after the fifth one. And here I'm doing a seeking thing. Get something at position 13. It comes out to be 13 in this case. Here, checking to see if that properly fails. And now what's this one? Still list one. Okay. I'll print out the two lists. These are from before. And now list 1 plus equals 1 plus 2. So you see, you can add them together. You can add one to itself. You can treat them like regular objects. So what that means, essentially, one thing that means is that you could, in theory, you could make a list of lists of things, you know, and I could add those other lists to a list of lists, and you can just go on forever. Because it's a regular object, it can be copied. It can be inserted into itself. The other thing is I added checks to make sure that you don't try to insert something from one list into a list that doesn't belong at. Let's see now. Do I have a position? Somewhere I do. Pause fifth. See if I try to put that into list 2, it should assert on me. So it's too big enough. Yeah. Should be. There you go. So it's not valid for that list. So a bunch of things, and other codes I'll uploaded. Other things I forgot to mention. You'll notice that I used a new keyword here, and I didn't explain it. And it's an important keyword. It's a fundamental keyword. This is the equivalent, sort of malloc for C++. Now, you've seen that I've been using malloc for things like just regular old strings, allocating regular old strings. But suppose I wanted to allocate one of these things, like a non-trivial object, a thing that has a constructor and a destructor and so on. In that case, malloc wouldn't work. The constructor wouldn't be called. If I wanted to make a pointer to one of these things that's allocated from the heap, I would have to say this. New, and then whatever constructor I want to use, choose the null constructor, or I can put a string in. Or whatever. Now, if I do this, you'll see that the constructor does get called, and that's what we want. But if I tried to malloc, no, I don't know if I go out of this. There, okay, see? The constructor got called, and so this p string is a valid string. The only thing is, it's not going to automatically delete it. Sorry, not going to automatically destroy itself. And the answer to that question, how to free it, is not to use free. You have to use the counterpart to new, which is called delete. So this will make sure that the destructor gets called. So new and delete go together like malloc and free. Okay, and there was one other addition to this pair, which is if you use new to allocate an array of complex objects, like an array of strings, syntax would be like this or something. Suppose I wanted an array of pointers to strings. Sorry, a new array of strings, I guess, right? So each element of that array is a string. I could say, I need a name for this. These are strings. Now where's the supply? Go here or here? Here it goes here. Alright, let's see. No, it goes here. Using semicolon. New string. Oh, I've got a name. The name's on the wrong side. So this is my pointer to strings. There we go. Now this has to be succeeded. I suppose, yeah. Now I should be able to say something like that, because when you dereference this pointer, you get the object. And that's fine. And then when I step over this, you will notice that the constructor will get, the default constructor will get called 5 times. Well, I don't know if it's, I'll put a breakpoint in it if we can get there. No, we need to get there somehow. Just want to put breakpoint so that we can stop there if that gets called. And in theory, it should get called 1, 2, 3, 4, 5. And call times. Okay. Now we're down here somewhere. Yeah. So now 5 constructors got called. But if we go and try and delete this thing doing this, that wouldn't work. Only one destructor would get called, and it would probably get called with the wrong pointer. In this case, you have to use a special operator with square brackets, which tells this thing that it was allocated as an array. And if you actually just go in memory and look, I'll show you in fact. It's kind of interesting. Okay. Implement this. And you wonder why they don't implement malloc in a similar way. I don't want that breakpoint anymore. Okay, P the strings, right? Memory. Write down P the string. Now it was on this line, right? F4, F4, and right ahead of that allocation is the number 5. Read backwards, that's 5. So this tells it how many string objects there are in the allocation. And that allows this operator to know how many times to call delete. And knowing the size of one of these things, it knows where to find the data that needs to be deleted. Okay, just wanted to let you know that. So this is just a little update. This source, as it stands, assuming it's not full of bugs, well, whether it is or isn't, is at the same location, and I think it's the number 8, the latest one, if you want to have a look. Okay, thanks.